Hi friends, this is Naresh. In this session, I am going to explain about design procedure of a engine, IC engine cylinders and cylinder liners. Okay, I will explain how to design internal combustion engine cylinders. Okay, and cylinder liners. This is a IC engine four cylinder multi-cylinder engine. So here four cylinders are there. So these are the cylinder bores. This is a cylinder block. Okay, this is the parts listed here. Yeah, this is a cylinder wall. Okay, this is a bore of a cylinder. These are the inlet and outlet walls. This is a spark plug or a fuel injector. Uh, for SI engines, we are using spark plug, that is petrol engines. In case of diesel engines, we are using fuel injectors. Okay, there is a spark ignition. Sorry, compression ignition. Okay, fuel injectors are used for compression ignition. Okay, we are we are providing a clearance between a cylinder top surface and top of the piston. Okay, this thickness of the wall is called cylinder wall, and this one is a piston. This is a piston pin. This is a connecting rod. This is a crank shaft. Okay, this is a crankshaft. This is a crank. Okay, this whole system is crank mechanism. Okay, the motion of this piston is in reciprocating motion. Okay, the length of here the piston moves from this point to this point. Okay, here you can observe here piston moves from here to here. So the length of this top dead center to bottom dead center is called stroke. Okay, stroke length. Okay, here this is the clearance. Okay, this is the clearance. Okay, this clearance is used for combustion. Okay, so this starting point, the top point is called top dead center, and bottom end is called bottom dead center. Okay, here I am going to explain about function of a engine cylinder. Here, what is the function of a cylinder in IC engines? The function of a cylinder is to retain the working fluid and to guide the piston. Okay, the function of a cylinder is to retain the working fluid and to guide the piston. Working fluid means diesel or petrol. Okay, so the main function of cylinder is to retain the working fluid and to guide the piston. So here you can observe here this piston moves inside the cylinder. Okay, the cylinders are usually made of cast iron or cast steel, since the cylinder has to withstand high temperature. Which okay, the cylinders are usually made of cast iron or cast steel. Okay, the material used for making the cylinder are cast iron or cast steel. For small engines, we are using cast steel. For large engines, we are using cast iron. Okay, since the cylinder has to withstand high temperature due to the combustion of fuel. Okay, some arrangement must be provided to cool the cylinder. A cylinder wall in an engine is under high temperature and high pressure, with the piston and piston rings sliding at high speeds. In particular, since long service life is required of engine for trucks and buses. Okay, Cast iron cylinders that have excellent wear resistant properties, okay, are only used for cylinder parts. Okay, these are the cylinder parts. Okay, now this is the working animation of a four-stroke engine, single cylinder four-stroke engine. Okay, here I am showing the four strokes. Okay, you can observe here. This is the outlet. This is the inlet. Okay, these are the walls. This is the outlet wall. This is the inlet wall. This is a cam. This is also cam. So this cam and collar mechanism is used to operate the inlet and outlet walls. Okay, this is the spark plug for spark ignition system. That is a petrol engines. Okay, here this is the cylinder. Okay, this is a cylinder. This is the thickness of a cylinder, and this is the bore. Okay, this is a bore. Bore means diameter of the cylinder, inner diameter of the cylinder. Okay, or diameter of the piston. Okay, this bottom case is called crank case. Okay, so these are the wall mechanisms to operate the inlet and outlet valves. Okay, you can observe here, this is outlet, this is inlet. Okay, engine cooling. Here I am going to explain about engine cooling systems. The single cylinder engines such as scooters and motorcycles, scooties, lonas are generally air cooled. They are provided with the fins. Okay, provided with fins around the cylinder. I will show some examples in next slide. The multi-cylinder engines, for example, cars, lorries, buses, okay, are provided with the water jackets around the cylinders to cool it. Okay, in smaller engines, the cylinder water jacket and the frame are made as one piece, but for all the larger engines, these parts are manufactured separately. The cylinders are provided with cylinder liners so that in case of wear, that they can be easily replaced. Okay, so this is the example for cooling fins. Okay, these cooling fins are used for single cylinder engines. Okay, this is a air cooling system. Okay, here the engine may cooled by air. Okay, so these projection ends are called fins. The single cylinder engines such as scooters, lonas, motorcycles, okay, are generally air cooled. They are provided with the fins around the cylinder. Okay, this is a cylinder. These are the fins. Okay, cooling fins are projections that increase the surface area from which heat can be radiated away from the device. Okay, the fins project outwards, making the area for emitting heat back into say an electric circuit containers smaller than the area emitting heat to the outside environment. The main function of this cooling fins are to transfer the heat from inside surface to the outside surface. Okay, so here the thermal conduction property is very important for engine cylinder materials. Okay, the engine cylinder materials should have high compression strength and a high thermal conductivity and low thermal expansion properties. Okay, so these are the another examples for fins. Okay, you can observe here. These are the fins used for single cylinder engines. These all are single cylinder engines. Okay, this is a bike. This is a spark plug. So this is a petrol engine. Okay, this is a petrol engine. Whereas for agriculture, diesel engines are also used air cooling systems. This is the cross-sectional view of a cylinder and cooling fins. Okay, these outside projections are cooling fins. Okay, this is the inlet and outlet walls. This is a spark plug hole, and this is a cylinder. Okay, so these all are examples for fins. Okay, this is a double cylinder engine, but here this is, it is uh, it is one cylinder, it is another cylinder, so both are making individually, so we are providing air cooling fins. Now it is a water cooling system. This diagram shows a water cooling system. Okay, this water cooling system is used for multi-cylinder engines for water cooling. Okay, the multi-cylinder engines such as buses, cars, lorries are provided with water jackets. Okay, this is water jackets around the cylinders to cool the engine. Okay, the temperature of the burning gases in the engine cylinder reaches up to 1500 to 2000 degrees Celsius, which is above multi-cylinder engine in tractors, trucks, and automobiles. So the cooling system is provided in the IC engine. Okay, so you can observe here. This is a spark plug. This is cylinder head. This is a cylinder wall, and this is a piston, and this one is a water jacket. Okay, this is a cylinder block. This is the for example for multi-cylinder, that is the four-cylinder uh, diesel or petrol engine. This is example for water cooling system for multi-cylinder engine. Okay, so this is a propeller. Okay, so this is a radiator, water radiator. Okay, so this is a crankshaft. Okay, this is a crankshaft, and these are the pistons and connecting rods. Okay, these are the cylinders and bores, cylinder bores and the cylinder liners. Okay, so this top horizontal rod is a cam and follower mechanism. Okay, these are the inlet and outlet walls. Okay, now I will show the cross-sectional view of this water cooling system. Okay, this is the cross-sectional view of a water cooling system. Okay, this is a propeller shaft, propeller or fan. Okay, draws in air through radiator to cool water. Okay, so this is a radiator. Okay, so this is a pressure release cap. This is a drain cock. Okay, so this is a overflow pipe. So this is a thermostat. It regulates the flow of water, and these are the engine cylinders. Okay, this is a water cooling system. Okay, this is a cylinder. Okay, cylinder block. Okay, these are the individual cylinders. Okay, cylinders with the liners. Okay, this is a pump. Okay, this is a pump. It is used for circulating the water through water jackets. Water jackets to cool to cylinders to cool the cylinders. So this is the example for multi-cylinder water cooling system. Okay. Now I am going to explain about liners, engine cylinder liners. This is the example for a liner. So the cylinder liner is a cylindrical part. Okay, this is a liners are in a cylindrical shape. Okay, a cylinder liner is a cylindrical part to be fitted into an engine block to form a cylinder. It is one of the most important functional parts to make up the interior of an engine. This is called cylinder liner in Japan. But some countries or some companies call this cylinder cylinder sleeve. Okay, these are main functions of the cylinder liners. I will explain. Cylinder liners are the interior metal components within the piston that protect it from the wear and tear operations of the motor. Three basic types of liners are used: hot, dry, and finned. Okay, here hot means wet liners, dry liners, and finned liners. Okay, the purpose of each type is to protect the piston from heat and impurities using slightly different methods. Cylinder liners are expensive, precisely manufactured products and are primarily purchased from specialty shops. Okay. Now I will explain different types of cylinder liners. This is a cylinder. Okay, these are the cylinder bores. Okay, this whole system is cylinder block. These are the cylinder holes. Okay, these are the cylinder liners. These cylinder liners are inserted into the bore of the cylinder. Okay, these are the different types of liners, cylinder liners. This is a dry cylinder liner. This is a wet type cylinder liner. This is a fin type liner. Okay, so you can observe here clearly the main difference between a dry liner, wet liner, and fin liner is its its outside body surface is different from one to one. Okay, here you can observe here for dry liners the surface of the liner is in uniform cross section. Okay, but in wet liners there is a grooves on the surface outside surface of the cylinder. Okay, here for fin liners it consists of fins. Okay, these are the fins to cool the cylinders. Okay, so these are the main difference between dry liner, wet liner, and fin liners are outside surface. Okay, inside surface is same for all type of liners. Now, now I will explain the definition of the dry liner and wet liner. A cylinder liner which doesn't have any direct contact with the engine cooling water is known as dry liner. Here you can observe here this is a cross-sectional view of a cylinder and cylinder liner. This is the assembled view of a cylinder and a cylinder liner with the water jackets. Okay, so here these you can observe here this is a water jacket and this one is a cylinder liner and this red color hatching line is a cylinder body. Okay, cylinder block. Here there is no direct contact between the water jacket and cylinder liner. Okay, there is no direct contact between the cylinder liner and water jacket, so such type of liners are called dry liners. Okay, if uh, if there is a direct contact between the cylinder liner and water jackets, then those type of liners are called dry liners. Sorry, those type of liners are called wet liners. Wet liners. Okay. Here you can observe here the main difference between dry liner and wet liner. Here in wet liner, sorry, in dry liners there is no direct contact. There is no direct contact between water jackets and liners. In wet liners there is a direct contact between the liners and water jackets. Okay, the cylinder liners are made from good quality close grained cast iron. Okay, so the material used for cylinder liners are grained cast iron, that is a paralytic cast iron, nickel cast iron, nickel chromium cast iron. Okay, So cast iron is used for making the cylinder liners. In some cases, nickel chromium cast steel with molybdenum may be used. The inner surface of the liner should be properly heat treated in order to obtain a hard surface to reduce wear. Okay. Now I will explain one by one clearly. Dry cylinder liners. Okay, already I have explained in previous slides. Okay, so in dry liners, there is no direct contact between the cylinder, water jackets and cylinder liners. Okay, yeah, this is the shape of a cylinder liner. This cylinder liner is inserted in the bore. Okay, this is the cross-sectional view of this cylinder liner. Okay. The dry liners are among the basic piston protectors. They must withstand extremely high temperatures and guard against impurities. So they are constructed of high-grade materials such as cast iron and ceramic nickel plating. Dry liners are much thinner than their counterpart, wet liners. They don't interact with the engine coolant, but instead provide a very close fit with the jacket in the cylinder block to protect the piston from heat and impurities. Wet cylinder liners. Already I have explained in previous slide. Here in wet liners, there is direct contact between the water jackets and the liners. Okay, this is the shape of a liner. Okay, you can observe here. These two are the different types of wet liners. These wet liners are used to multi-cylinder engines. Wet cylinder liners protect the pistons in a different way than dry ones, but they are made from the same hardy material. They come in direct contact with the engine coolant. Sometimes the wet cylinder liners are fitted with the tinny openings. Okay, tinny openings to help disperse the heat and impurities. These types of liners are called water jacket liners, but are simply another type of wet liners. If the liner doesn't have a cooling jacket, one is created by the liner by interacting with the jacket present in the cylinder block. This is the last type of cylinder liner, that is the finned cylinder liners. Okay, so here the outside of the liner consists of cooling fins. Okay, finite cylinder liners are constructed of the same type of heat and impurity resistant metal. This type of liner is designed for the air cooled engine. Okay, and in operation works much like the dry cylinder liner in that the cooling medium for the motor is air. Okay. Moreover, these liners are fitted with tinny fins, which allow inflowing air to draw with great force around the cylinder to provide cooling. Okay. So, finned cylinder liners are used for air cooling engines. Okay, that means uh, bikes, scooters, lonas, that type of two-wheeler vehicles. Okay, in two-wheeler vehicles, this type of cylinder liners are used. Okay, dry liners and wet liners are used for water cooling systems. Okay, now this is the now I am going to explain about design procedure of a cylinder and the cylinder liner. Okay, in design a cylinder for an IC engine, it is required to determine the following values. The cylinder wall is subjected to gas pressure and the piston side thrust. Okay, the gas pressure produces the following two types of stresses. Okay, okay, friends. ఇక్కడ మనకి ఈ సిలిండర్ అనేది మనకి ఈ సిలిండర్లో టూ టైప్స్ ఆఫ్ స్ట్రెస్సెస్ అనేవి మనకి డెవలప్ అవుతాయండి. ఒకటి ఇక్కడ పైన మనకి ఫ్యూయల్స్ అనేవి బర్న్ అవుతాయి. సో ఫ్యూయల్స్ బర్న్ అయినప్పుడు మనకి గ్యాస్ ప్రెషర్ అనేది ఇక్కడ గ్యాసెస్ గ్యాసెస్ అనేవి క్రియేట్ అవుతాయి. ఆ గ్యాసెస్ వల్ల మనకి ప్రెషర్ క్రియేట్ అయింది. ఆ ప్రెషర్ గ్యాస్ ప్రెషర్ అంటాం. ఆ ప్రెషర్ అనేది ఈ సిలిండర్ వాల్స్ మీద యాక్ట్ అవుతూ ఉంటుంది. ఓకే అండి. సో అది హై అమౌంట్ ఆఫ్ ప్రెషర్స్ అండి. సో ఆ లోడ్ కంపల్సరీ మనం కన్సిడర్ చేయాలి ఆ గ్యాస్ ప్రెషర్ అనేది. ఇంకొకటి సెకండ్ టైప్ ఆఫ్ స్ట్రెస్ ఏంటంటే ఈ పిస్టన్ అనేది రెసిప్రోకేటింగ్ మోషన్లో మూవ్ అయినప్పుడు, అంటే దట్ మీన్స్ అప్ అండ్ డౌన్, ఓకే, పైకి కింద మూవ్ అయినప్పుడు ఇక్కడ మనకి సిలిండర్ సర్ఫేస్కి పిస్టన్ రింగ్స్కి పిస్టన్ సర్ఫేసెస్ మధ్యలో ఇక్కడ రబ్బింగ్ అనేది జరుగుతూ ఉంటుందండి. ఓకేనండి. సో పిస్టన్ రింగ్స్కి ఈ సిలిండర్ లైనర్కి మధ్య ఇక్కడ రబ్బింగ్ అనేది జరుగుతూ ఉంటుంది. అంటే ఇక్కడ రబ్ అవుతూ ఇక్కడ మనకి పైకి కింద మూవ్ అయినప్పుడు ఇక్కడ ఈ వాల్స్ మీద ఈ సిలిండర్ వాల్స్ మీద ఈ లైన్ ఈ ఈ పిస్టన్ రింగ్స్ వల్ల కొన్ని థ్రస్ట్ లోడ్స్ అనేవి యాక్ట్ అవుతాయండి. ఆ థ్రస్ట్ లోడ్స్ వల్ల మనకి స్మాల్ అమౌంట్ ఆఫ్ స్ట్రెస్సెస్ అనేవి మనకి అక్కడ జనరేట్ అవుతుంది. సో అది చాలా స్మాల్ వాల్యూ. సో యూ కెన్ నెగ్లెక్ట్ థ్రస్ట్ థ్రస్ట్ లోడ్స్. ఓకే, you only can concentrate on gas pressures. Okay, here there are two types of stresses are developed in the engine cylinders. That first one is the longitudinal stress and second one is circumferential stress. Since these two stresses act at right angles to each other, therefore the net stresses in each direction is reduced. The piston side thrust tends to bend the cylinder wall, but the stress in the wall due to side thrust is very small and hence it may be neglected. Okay, side thrust అంటే ఈ పిస్టన్ కి సిలిండర్ వాల్ కి మధ్య ఉండే సైడ్ థ్రస్ట్ అనేది ఇక్కడ చాలా స్మాల్ వాల్యూ. సో యూ కెన్ నెగ్లెక్ట్ ఇట్. ఓకే, now I am going to explain the design steps. Here there are four steps to design the cylinder and cylinder liners, cylinder cap and cylinder bolts. Okay, so the first step, in first step we are going to design the size and length of the cylinder. Okay, here the diameter of the inside diameter of the engine cylinder is called bore. So in this step we are going to design a bore and length of the cylinder. So here you can observe, here this is the stroke length. Okay, so this is the stroke length and this is the thickness of the wall. Okay, and the inside diameter of the cylinder is called bore. Okay, bore means the inner diameter of the cylinder or outer diameter of the piston. Okay, and the outside diameter here the length required to bear the gas pressures, length of the cylinder L equal to 1.15 into LS. Here LS is the stroke length. Okay, LS is the stroke length and L cylinder, it is L cylinder is the length of the cylinder. Okay, here this is the, from here to here this is the length of the cylinder. Okay, so this is a LC, this is the length of the cylinder. So the length of the cylinder equal to 1.15 into stroke length. So this is stroke length. Okay, this is the clearance. Okay, so this clearance is nearly equal to 0.15 0.15%, 15% of the stroke length. Okay, we provide the gap or clearance equal to 0.15 ls, that is 15 percentage of stroke length. So this is the main formula for engine cylinder length. So for here the stroke length the length of the stroke is obtained from the formula, that is ip equal to pm ls an by 60. The units for ip means indicated power. The units for indicated power is in watts. Okay, yeah, there is another formula is there, that is ip equal to bp. Yeah, once is it indicated power equal to brake power. BP means brake power divided by mechanical efficiency. This is zeta mech. Zeta mech means mechanical efficiency. Okay, these two are the formulas for indicated power. Okay, here PM is the mean effective which here ls is the stroke length. Okay, here from here to here, this is the stroke length. That is the distance between top dead center and bottom dead center is called stroke length. And here the value of a stroke length is 1.25, varies from 1.25 d to 2d. Here capital D is the inside diameter. Here this is the bore. This is the diameter D. Okay, this is the bore diameter. Okay, so the stroke length ls varies from 1.25 times the diameter of the bore to 2 times the diameter of the bore. Okay, the stroke length lies between 1.25 to 2 times the diameter of a bore. Okay, and the cross sectional area of the bore is pi over 4 d square. Here the shape of, we consider the shape of a cylinder is in circular cross section, so therefore the cross section area of the cylinder we treated as circular. So the area for circular cross section A equal to pi by 4 d square, and PM is the mean effective pressure. Okay, this is in Pascal or megapascal, and N is the speed of the engine in RPM. Okay, N is the speed of the engine in revolutions per minute. RPM means revolutions per minute. But the value of N is different for two-stroke engines and four-stroke engines. Here you have in our problems, you have to consider N equal to N. Okay, N equal to N for two-stroke engines. Okay, N equal to N by 2. Okay, N equal to N by 2 for four-stroke engines. Okay, so this is the main important one for our problems. So for two-stroke engines, so you have to consider given speed of engine as same. Okay, you have to substitute N equal to N in this formula for two-stroke engine. But four-stroke engines, you have to substitute N equal to N by 2. Okay, so from this IP formulas, from indicated power formulas, you can get the value of diameter and stroke length. Okay, both values are obtained from these three formulas. Okay, from these two formulas, we got a bore diameter, that is capital D. After getting the capital D, we substitute the value D in this equation. Then we got ls. This then after you have to substitute this ls value into this equation. Then finally you will get length of the cylinder. Okay, so these are the main formulas for design of the bore length. Okay, now here capital D is the bore diameter or internal diameter of the cylinder, and D naught is the outer diameter. Okay, yeah, outside. Yeah, you can observe here. So this one is inner diameter, and this one is outer diameter. This is D naught. Okay, D naught. This is D naught, and this is D. Okay, inside diameter is also called bore, and D naught equal to outer diameter of the cylinder. Now this is the thickness. This is the thickness of the cylinder. Okay, this is a thickness of a cylinder. Okay, this one also same, thickness is same. Okay, T is the thickness. Okay, and 1 by m, 1 by m or mu is the Poisson's ratio. Uh, the value of Poisson's ratio you can take 0.25. Okay, Poisson's ratio means the ratio of lateral strain by linear strain. Okay, so for our subject point of view, we consider Poisson's ratio as 0.25. There is no units for Poisson's ratio because the formula for Poisson's ratio as lateral strain by linear strain. So both are strain, numerator and denominator both are strains. So there is no units for strains. So here there is no units for Poisson's ratio. And sigma ut, it is also very important for remaining steps. Here sigma ut is the ultimate tensile stress and fs is the factor of safety. Okay, so these are the main formulas used in our design of bore and stroke length. Okay, here these three formulas are main. Okay, length of the cylinder equal to 1.15 into stroke length. Okay, here the stroke length equal to LS equal to 1.25 D to 2D. So here the diameter or bore of the cylinder is obtained from these two formulas. By using any one of these two formulas, you can get the value of D. Okay, after getting the bore diameter, then you have to substitute the value of D into this equation. Okay, so this is step 1. Now I am going to explain about step 2, that is thickness of the cylinder. Thickness of the cylinder means this one, thickness of the wall. Okay, in second step I am going to design a thickness of the wall. Okay, thickness of a cylinder wall. So thickness of the cylinder wall is denoted by symbol T. Okay, the formula for thickness of the cylinder wall, T equal to PD by 2 into sigma C plus C. Okay, this formula is obtained from our previous subject, a previous semester subject, that is mechanics of solid subject. Okay, already we have discussed in previous semester, that is a thin cylinders and thick cylinders unit. Already we have discussed in that unit, that is this is the formula for thickness of a cylinder, thickness of a thin cylinder. Okay, here you treated the engine cylinder as a pressure vessel. Okay, so here the thickness of the engine cylinder T equal to PD by 2 into sigma C plus C. Here P is the inside pressure. Okay, P is the inside pressure in the cylinder, and capital D is the bore diameter or inner diameter of the cylinder, and sigma C is the stress. Okay, sigma is the stress, compressive stress. Sorry, circumferential stress. Sigma C is the circumferential stress. Here sigma C is the circumferential stress plus capital C. Capital C is the constant value. This capital C value is obtained from this tabular form. Okay. Okay, by using this formula, you will get the value of wall thickness of the cylinder. Okay, P is the inside pressure, D is the bore diameter or diameter of the cylinder. This is the inner diameter of the cylinder. Capital D is the inner diameter of the cylinder. Okay, capital C is the constant value. So this constant value is obtained from this table. Okay, the capital C value is obtained from corresponding diameter of the engine. Okay, so here P is the maximum inside gas pressure. If it is not given in our question, then you can take inside pressure, maximum inside pressure P equal to 9 times the mean effective pressure. Okay, 9 times to 10 times the mean effective pressure. If it is not given, you can take this value. Okay, now T is the thickness of the liner or cylinder wall. Capital C is the elements for reboring. Okay, capital C is the constant for reboring elements. Okay, reboring elements అంటే మనకి ఈ సిలిండర్ని యూజ్ చేయగా కొన్నాళ్ళకి తుప్పు బట్టి లోపల బోర్ అనేది మనకి తుప్పు పట్టడం కానీ లేదంటే కొంచెం అరగటం కానీ అంటే మనకి బోరికి వచ్చినప్పుడు బండి లైనర్స్ యొక్క సర్ఫేస్ అనేది అరుగుతూ ఉంటుందండి. సో అందుకని మనం దానికోసం ఎలిమెంట్స్ అనేది ఎక్స్ట్రా థిక్నెస్ అనేది మనం ప్రొవైడ్ చేస్తాం. ఓకే అండి, సో ఆ ఎలిమెంట్స్ ఇది. ఓకే అండి, ఎక్స్ట్రా థిక్నెస్ అండి ఇది మనం ప్రొవైడ్ చేసి సిలిండర్ యొక్క టైప్ను బట్టి సిలిండర్ యొక్క డయామీటర్ని బట్టి ఎక్స్ట్రాగా మనం కొంత థిక్నెస్ అనేది ప్రొవైడ్ చేయాలి. ఓకే అండి, ఎందుకంటే తర్వాత అరిగిపోయినప్పుడు అది సెట్ అవ్వడానికి. ఓకే, now this is the formula for apparent longitudinal stress. Okay, sigma L is the apparent longitudinal stress. The formula for apparent longitudinal stress is d square P by d naught square minus d square. D naught is the outer diameter. Okay, d naught is the outer diameter of the cylinder, capital D is the inner diameter of the cylinder. Okay, P is the maximum inside pressure. Okay, and this is the formula for apparent circumferential stress. The formula for circumferential stress equals sigma C equal to PD by 2T. Okay, this formula also obtained from our previous subject, mechanics of solids. Okay, and if it is not given, then you can use this formula also, sigma C equal to sigma T equal to sigma UT by Fs. Okay, sigma UT means ultimate tensile stress. Ultimate tensile stress by factor of safety. Fs means factor of safety. Okay, sigma T is the tensile stress, or sigma C is the circumferential stress. Now, net longitudinal stress. Net longitudinal stress is equal to sigma L minus sigma C into 1 by m. Okay, net circumferential stress equal to sigma C net equal to sigma C minus sigma L into 1 by m. Okay, these are the formulas for design of engine cylinder thickness. Okay, and another formulas are also there. These are the empirical formulas. The thickness of the cylinder wall may also be obtained from the following empirical relation, that is thickness T equal to 0.045 D plus 1.6 mm, and thickness of the dry liner T DL equal to 0.03 D to 0.035 D, and thickness of the water jacket wall equal to TWJ equal to 0.032 D plus 1.6 mm. Water space between the outer cylinder wall and the inner jacket wall is equal to 0.08 D plus 6.5 mm. Okay, these are the main formulas used for design of cylinder wall thickness. Okay, this is the step 2. Okay, step 2 is completed. Okay, now I am going to explain about step 3, that is design for thickness of cylinder flange. Cylinder flange and studs. Studs are bolts used for covering the flange. Okay, these are the important formulas for this cylinder flange. The thickness of cylinder flange and studs are bolts. Thickness of the thickness of flange. The formula for thickness of flange TF equal to 1.2 times 1.2 to 1.4 times the thickness of the cylinder wall. Okay, now number of studs used for covering the flange is equal to ns. Number of studs or number of bolts used for covering the flange is equal to ns. Okay, so the minimum number of studs equal, the formula for minimum number of studs equal 0.01 d plus 4, maximum number of studs equal 0.02 d plus 4. Okay, and here the nominal diameter of the stud or bolt, dm equal to, here dm is the nominal or major diameter of the stud bolt, that is also outside diameter of the bolt. Okay, core or minor diameter of the stud or bolt equal to ds. This one also called root diameter. Okay, ds. ds is the root diameter or minimum diameter. Okay, the formula for major diameter of the stud bolts equal dm equal to ds by 0.8. That means core diameter is equal to 0.8 times the major diameter. Okay, the formula for ds, that is the diameter for core diameter of the stud, ds equal to square root of d square into p by ns into sigma ts. This is the formula for the diameter of the core. Okay, so by using this formula, you will get the value of ns. Pitch of studs, the formula for pitch of studs, dp equal to capital D plus 3d, and minimum pitch equal to 19 square root of dm, and maximum pitch equal to 28.5 square root of dm. And here sigma ts, here this one is sigma ts, is the allowable tensile stress for the material of studs. Okay, this is the sigma for tensile stress for stud materials. Okay, if it is this, the value of this tensile stress is not given, if it is not given in our problem, then you will take you can consider sigma ts equal to 35 to 70 megapascal. Okay, this is the approximate value for bolt materials. And this is the last step for design of engine cylinders. Here step 4 is the thickness of cylinder head. Okay, the cylinder head may be approximately taken as a flat circular plate whose thickness th may be determined from the following relations. Okay, th is the thickness of the cylinder head. Okay, so this is a top cover plate of the engine cylinder. So we need to design the thickness of the cylinder head. So th equal to square root of 0.162 p p into d square by sigma c. Here capital P is the inside maximum pressure, and capital D is the bore diameter or inner diameter of the cylinder. Okay, capital P is the inside maximum pressure in the cylinder. Now sigma c is the circumferential stress. Okay, by using this formula you can get the value of cylinder head thickness. Okay, here the value of the formula for sigma c equal to sigma t equal sigma ut by fs. Okay, if it is not given in our problem, then you can use value 30 to 50 megapascal for sigma c. Okay, this is the last step for design of engine cylinder. Okay, so here totally 4 steps are there for design of engine cylinder and cylinder liners. Okay, so I completed those 4 steps. Okay, so in next class I will explain with one example problem for design of engine cylinder and cylinder liners. Okay, by using these 4 steps you can design any type of problem on engine cylinders and cylinder liners. Okay, only one model is there on design of engine cylinders. Okay, so in next class I will explain with simple example. Okay, okay friends, thank you.